Okay, hello everybody. I'm making this video because I wasn't able to get to the last few slides and you're going to need them for the homework and for the quiz. So please just use open notes for the quiz. Please don't look anything up. You can watch this video and refer to it if you need to in order to be able to have the best time completing your homework. Okay. So let's get started. So this is the last slide that we left off on. It's a little bit about rounding and sig figs. All right, so let's go to dimensional analysis. So specifically what dimensional analysis is a way of converting one unit to another. And we do this by using conversion factors. So this is when you can set one unit to equal another unit. So that would be something like inches to feet, where there's 12 inches in 1 feet. That would be a conversion factor. It's a ratio of two equivalent quantities expressed with different measurement units. And so these are some common conversions that we're going to be using. Again, I'm going to be making a little bit of a cheat sheet for you guys that's going to have some of these on it and some equations as well that you'll be able to use to figure out exactly what you need to use in order to convert things. You don't have to memorize everything. Especially things where you go from imperial to SI units. The only thing that I would suggest is maybe the inches to centimeters. That one's going to come in handy. Maybe kilograms to pounds. Not super important, but it might come up. Everything else though is going to be we're going to get to that when we get to it. So to use dimensional analysis, there's a couple ways you can do this. This is the way that I do it. I call it the train track method. It is also called the ladder method. There's a lot of different names for it, but let's use it to convert 1 inch to feet. The first thing that you're going to want to do is you're going to want to draw this little plus sign or this kind of scaffold. This is what your train track is going to be. And this can be very long, it can be short. For this, it depends on how many conversions you need to make. And so for this first one, we're just going to use 1 because we just need to go from inches to feet. And so in your upper left corner, you're going to put whatever unit you're starting with. So we are starting with 1 inch in feet. And note that I have two different significant figures here. In the right-hand corner, we are going to put whatever unit that we need to end up in. We're converting inches to feet, and so feet is where we're going to end up. Nothing is going to go into the bottom left corner, and we can assume that this is 1. This is because these train track things, each of them are fractions. So if you have 1 inch divided by 1, that's just going to give you back 1 inch. So nothing goes in the bottom left corner. Eventually, we may use things that will go in the bottom left corner, but for right now, we're not going to. So, if we move on, we're going to talk about the bottom right corner, or whatever is going to be diagonal from wherever you start. So, if you have a unit that is in the top left, we need to put the same unit in the bottom right, whatever's diagonal to that unit in the top left, and then we can use that to cancel it out. So inch is going to be canceled out by inches. You can consider it to be like you have whatever the number is multiplied by 1 of whatever the unit is. So 1 inch is going to cancel out with 1 inch. 1.0 times 1 inch is the 1 inch is going to cancel out. This would be 12 times 1 inch, or so those would cancel out. You are going to then put whatever needs to be converted to on the top. And so keep in mind here, this is a question that I get quite often when we're doing this, is where do I know where to put things? Well, where do I know where to put numbers? The first thing is you need to cancel out units. So whatever your top unit is has to cancel out with whatever the bottom unit is. And then you have to use your best judgment here, but we know that there are going to be more inches in a foot than there are feet in inches. So the 12 is going to go on the bottom because that's the larger number. You need more inches to go into 1 foot than you do feet to go into 1 inch, or than you do feet to go into inches. So the larger number is going to go on the bottom, so we can convert to a smaller number. Only the unit that is in the top right is going to be able to be canceled, or it's going to be able to be remaining. All other units, no matter how long we make this, are going to cancel out. Okay, and so then let's go about doing this. So what we need to do is we need to multiply all of the values on the top together. So that's what we have here. We have 1.0 times 1, and that is going to give us just 1. And then remember that this over here in the bottom left corner, this is equal to about 1 with no units. It's equal to 1 with no units, and so we can just ignore it, and we can just say that the only thing we care about is the units and the numbers on the bottom right here. And we'll just multiply across again. That's going to be 1, or just something that doesn't exist, times 12. It's going to give us 12 on the bottom. And so now we have another fraction. We have 1.0 times 1 divided by 12. And this is going to be where we get our answer from. The next thing that we do is we will complete the calculation by dividing the top by the bottom. That's going to be 1 divided by 12, which gives us 0.08333. And then we account for sig figs, and since we only have 2 significant figures over here, we end up with only 2 significant figures in the end. And so this is going to be a problem that you can try on your own. So if you'd like to give this a shot on your own, then go ahead and pause the video here, and I will go ahead and pause the video here. Give yourself some time to try this out. I'll pause for a second before I show the rest, but these are going to be all the conversion factors that you need. Okay, I'll pause here for just a second, and you can give it a shot. Okay, so let's proceed. So first, I want to convert each of these things. So we know that 1 fruit by the foot, well, I'll explain each of these, We know that 1 fruit by the foot is about a yard. So we'll say that it equals 1 yard. We know that a yard is 3 feet, a foot is 12 inches, an inch is 2.54 centimeters, 100 centimeters is a meter, and a meter is 1 to the 10 angstroms. Now, what we're trying to do is we're trying to see how many angstroms long this, if I had 1.35 fruit by the foot, would be. And so let's continue. So the first thing that you want to do is you want to make a train track that is going to have a slot for each one of your conversion factors. You can call this like a rail or something, or a cell. Each of the rails is going to have its own conversion factor. So first we need to go from fruit by the foot to yards, from yards to feet, from feet to inches, inches to centimeters, and centimeters to meters, and then meters to angstroms. That's what this symbol is right here, is an angstrom. And it's about the width, I think, of a it's what we measure the size of atoms on. So that's what we're going to do here. And so we're going to arrange them in a way that they can be canceled out. Remember, that is going to be on the diagonal. And then we can plug in the numbers. So 1.35 fruit by the foot. We know that there's 1 fruit by the foot in 1 yard, 3 feet, etc., etc. This last one, remember that there are the larger value is going to go with the smaller unit. So 10 to the 10th is going to go with the smaller unit, which is angstroms. 1, which is the smaller number, is going to go with meters. You have the same thing over here with centimeters and meters, exact same thing. And so once we've plugged in all the numbers, then we can start crossing everything out. We're going to cancel out all of the units. Fruit by the foot, yards, feet, inches, centimeters, and meters are all going to cancel out. The next thing we do is we're going to multiply across. So that's going to be 1.35 times 1 times 3 times 12, 2.4, 1, 10 to the 10th. And we're going to do the exact same thing on the bottom, and we get this number, 1.233344. And remember, before you're done with your calculations, if you get a large number that has a continuous value at the end, you want to make sure that you put one more decimal place greater than the lowest decimal place, or one more significant figure greater than the smallest, or greater than the largest significant figure. Or you can use 2 like I did here. It doesn't really matter. You're going to trim it down later, but the more accuracy in your calculations, the better your number is going to turn out in the end. And so I put this into scientific notation here, because this number is very large. It's going to be 10 to the 12th angstroms. That's very, very large. So I did this to just save some space. And on the bottom I showed that 100 can also be expressed as 10 to the second. So you can use 100 here, or you can use 10 to the second. Either one's fine. But then you take the top, you divide it by the bottom, you end up getting 1.23 times 10 to the 10th angstroms. Okay. And yeah, 1.23 times 10 to the 10th angstroms is where we're going to end up, and that's the answer to the problem. So if we consider a hydrogen atom, I believe it is about an angstrom long, I don't quite remember, but we could say that this is 1.23 times 10 to the 10th angstroms long. That is the size of 1.35 fruit by the feet. Okay, here is another problem for you guys to solve. This is how it is going to work out. Tungsten is an incredibly hard and expensive metal. In an incandescent light bulb, there is about 17.6 milligrams of tungsten making up the filaments. That's that little wire that's in a light bulb, in a classic light bulb. And if we want to see how much this is in pounds, we're going to have to convert it. So we can convert from, well, go ahead and give this a shot as well, and then I will be back with the answer momentarily. So, what we're going to do next is we're going to go ahead and solve this. The first thing that we need to do is we need to make a train track with all of the units that we're going to cancel out. So we have milligrams of tungsten, we have grams of tungsten, and kilograms of tungsten. We know we're starting with milligrams because that's what we began with. That's the information that we have. We know we want to end in pounds of tungsten. And the next thing we'll do is we'll fill in those values. So we know that we started with 17.6 milligrams of tungsten. We know that there's 1,000 milligrams of tungsten in 1 gram of tungsten, 1,000 grams in 1 kilogram, and 1 kilogram is equal to 2.2046. And I got this conversion factor from the a slide earlier where I showed some of the conversion factors. And keep in mind that this W, that is the chemical symbol for tungsten, wolframite or something like that. You do not have to include that if you don't want to, but I'm just doing it here so that we can be clear about exactly what we're doing. Okay, and so the next thing we'll do is we need to cancel out all of the units, make sure that they cancel out, otherwise we will not have the correct number in the end if they do not cancel out. And we'll multiply across 17.6 times 1 times 1 times 2.2046 divided by 1,000 times 1,000. And that's going to give us the answer of 3.88 once we round for sig figs times 10 to the negative 5th pounds of tungsten. Okay. Alright, so one last thing I would like to go over that we will use some of, but I don't have any practice problems for this. It's not on your homework, it's not on your quiz, but it is something that we will need to use. Okay, so percentages. Percentages give the number of objects per 100 objects that you have. And so what that means is that, for example, if you had 35 orange jelly beans out of 100 orange jelly beans, 35% of the jelly beans are going to be orange. And this is calculated like this. We have 35 orange jelly beans divided by 100 orange jelly beans, and we'll multiply that by 100, and this is going to be our unit for percentages. This percentage is going to be the unit. If we didn't include the 100%, then we would get a fraction of 1, or sorry, a decimal of 1. We would get 0.35. So we multiply it by 100 to say that there's 35% present. And so we will be using these for many different things, and we're not going to use clean numbers like 100. The number 100 comes from this right here, but it could be out of 101. It could be out of however many jelly beans you have. Whatever the maximum is that you have, that's what we'll be dividing by. And we are going to be using this for things like mass percent, mole percent yield, percent error. We might use it for percent catalyst. I haven't seen that being used yet, but we'll explain it when we get closer to that point. We'll cover these moving forward, but for now, just know that percentages are coming, and if you would like, you can practice. I can give you some resources to do so. And so this is the homework. Just as a note, I will be sending out an announcement shortly to explain a little bit more about the homework. I'm going to change it up a little bit. Appreciate your patience with me this far. I am just working to make this class as transparent as possible and easy to follow, but it's just going to take a little bit of work to get there. But these are the homework problems, and the reason that I'm going to be changing it just a little bit is that I was not able to find where I got that 11th edition of the Ebbing and Gammon book easily. And so instead I will be either using the 9th edition, or I will accept both the answers from the 9th edition and the 11th edition. The 9th edition is much more easy to find for free out on the internet. Unfortunately, due to copyright law, I'm not allowed to just hand you the book that I have, but you can definitely find the 9th edition available on the internet. Okay, and I believe that is it. Thanks so much. I will see you guys soon.